video is a review of the Edgenuity lesson using triangle similarity theorems. So what they start off talking about in the lesson is if you have a triangle here and you have two sides that are parallel here, so there's like a little mini triangle up here, DCE, and then the big triangle, BCA. If you know these two sides are parallel, you can write a proportion of their side lengths. So the way that I think of it is I just, wherever that parallel line is, I just draw a big line, and I imagine that that's my fraction bar. It helps me set up the proportion. So if I imagine that as a fraction bar, what we end up with is 4/8 has to equal x over 12. And so we can use that proportion to help us solve for side lengths. So our question is, what is the length of EC? So I can just solve this proportion. And to solve proportions, what you do is you cross multiply. So I would say that 4 times 12 has to equal 8 times x. And to get x by itself, I'm going to divide both sides by 8. So x is 6. So this length of EC here has to be 6 for those two lines to be parallel to each other. The second example here, it says, is segment MN parallel to segment GH? So we don't know whether or not these are parallel or not. We have to figure that out. So if they are parallel, the length should be proportional. So again, I'm going to imagine this as a big fraction bar. So if I wrote that fraction, so this is the bar, I would go 48 over 16, does that equal 56 over 21? So if I cross multiply here and I don't get the same thing, then these cannot be parallel. They have to be proportional. So 48 times 21, does that equal 16 times 56? 48 times 21 is 1008. And 16 times 56 is 896. So those are not equal to each other, so that means they are not parallel. The next thing that they talk about in the video is the mid-segment theorem. And what that says is if you connect midpoints, so if I have the midpoint of ST is W and the midpoint of RT is U, if you just connect them, then that becomes a mid-segment. And the mid-segment is always parallel to the base it goes with. So those two lines are going to be parallel right now, right there. And then this is going to be half as big. So for example, not using these numbers, if this was 10, I know this is 20. If this was 50, I know that this would be 25. So that, again, the mid-segment is parallel to the base it goes with, and it's also half as big. So here in our question, it says segment UW and segment VW are mid-segments of triangle RST. So we need to find the length of UW and RT. Okay, so here's UW. It's the mid-segment, so it's going to be half as big as RS. So if RS is 12, this has to be 6. We also need to figure out what RT is. Okay, so here's RT. Its mid-segment is 8. So if this is 8, we just double it to get the base that goes with it. So 8 times 2, this is going to be 16. Down here it says which lines are parallel. So UW is going to be parallel to RS. And also that mid-segment is going to be parallel with its base. So VW is parallel to RT. The next question says T if SW is 7. So if SW is 7, now as a reminder, this is the midpoint, so it's cutting this in half. So if this is 7, this side is also 7, which means the whole length ST is 14.